Hello, welcome. Today we're going to talk about something remarkable. The theory that the sun may have an evil twin. Did you know that the vast majority of stars do not travel alone through the universe, but instead move alongside a gravitational sister? There are hints of a colossal force that returns to our cosmic neighborhood every 26 million years. Could there truly be a dark twin, named Nemesis, that brings chaos and disruption to the solar system whenever it draws near? In this journey, we will explore the theory of this possible evil twin and imagine what our lives might be like if we had two suns in the sky. We'll also discuss what leads scientists to suspect that such a star might exist and how it could help explain some of the great mysteries in Earth's distant past. Before we continue, I'd like to ask for a small moment of your support. If you enjoy calm explorations of science like this, consider subscribing and sharing the channel with someone who might also find rest in these cosmic stories. Your support quietly helps keep Cosmos for Rest alive and growing. Now, allow yourself to relax. Gently close your eyes, and let science guide you. To understand the story of this lost sibling, we need to step back in time, long before planets existed, before oceans formed, before any eyes were turned toward the sky. We must travel to the moment when the sun itself awakened to the light. Imagine a cosmic nursery, an immense cloud of gas and dust drifting in the silence of space, vast like an ancient dream. In these regions, gravity works like a patient artisan, gathering scattered matter, grain by grain, atom by atom, until the pressure becomes unbearable and a new star ignites in the darkness. It was this way, amid a chaos that was both creative and beautiful, that our sun was born. But science tells us that stars rarely come into existence alone. They are born in litters, clusters of sister stars formed within the same nebula, sharing the same origin and the same chemical composition. When we look into the depths of the galaxy, we notice a fascinating and almost universal pattern. The vast majority of stars shining in the night are not solitary travelers. They have companions. They dance in pairs, sometimes even in trios, bound by an invisible and eternal tie we call gravity. Think of Alpha Centauri, our closest stellar neighbor. There is not just one sun, but three, turning together in a complex and elegant choreography. Think of Sirius, the brightest star in our night sky, which also does not stand alone. It is accompanied by a small white dwarf, a discrete partner that follows it through eternity. This is the rule of the cosmos. The universe seems to prefer duality, a balance between two bodies orbiting a common center, as if solitude were an unwanted exception in the grand tapestry of stars. And here lies the great mystery that brings us to this moment of reflection. Our sun, the star that warms our skin and sets the rhythm of our days, appears to be that exception. It reigns alone and sovereign at the center of our system, with no other star to share its gravitational stage. For a long time, we accepted this solitude as a simple fact, a natural characteristic of our address in the universe. We look up during the day and see only one source of light. Night belongs to the other stars, distant and unreachable. Yet the human mind is restless and always searching for patterns. When astronomers began mapping the architecture of stellar systems, the sun's solitude started to feel like a puzzle. If nature favors pairs, if the physics of star formation tends to create multiple stars from the same cloud, where would our other half be? Was the sun truly destined to wander alone? Or did we miss something in the vast darkness that surrounds us? This is where the theory of Nemesis is born, not as an absolute certainty, but as a possible answer to the questions returned by the silence of space. The hypothesis suggests that the sun is not single, but instead lives in the longest long-distance relationship imaginable. The idea is that we were indeed born with a sibling, a second star formed in the same primordial cloud, but which, through the whims of orbital dynamics, was thrown into an extremely wide orbit, far beyond the planets we know, far beyond the realms of Pluto or Neptune. Imagine this celestial body. It would not be bright and imposing like the sun. If it exists, it is likely a red dwarf, small and cool, or perhaps a brown dwarf, a failed star that never gathered enough mass to ignite nuclear fusion in its core. It would be a traveler of shadows, a discrete celestial object almost invisible to our telescopes, lost in the black depths of interstellar space. It would be so distant that the light of our sun would reach it only as the faint glow of an ordinary star. And likewise, for us, it would appear as just another pale dot, indistinguishable among millions of others scattered across the sky. The name Nemesis comes from Greek mythology. the goddess of inevitable retribution, the one who ensures that destiny is fulfilled. In astronomy, the name carries a poetic and somewhat ominous weight. It was chosen not because the star itself would be malicious. After all, stars have no intentions. They simply follow the laws of physics, but because of the effect its presence could have on us. The theory proposes that this lost sibling is not stationary. Instead, it travels along a gigantic orbit, an elongated ellipse that takes ages to complete. We are speaking of a slow dance, almost imperceptible on human timescales. While Earth circles the Sun once each year, Nemesis would take millions of years to complete a single revolution around the shared center of mass it holds with our Sun. It is a rhythm of time so vast that it challenges our everyday understanding. Empires rise and fall, species evolve and vanish, continents separate and reunite. And throughout all of this, Nemesis would have traveled only a small fraction of its silent path along the outer borders of the solar system. But the theory suggests that this distance is not constant. As with any elliptical orbit, there is a moment of greatest separation and a moment of approach. And it is during that approach that the story becomes fascinating and, in a certain sense, unsettling. It is believed that when Nemesis reaches its closest point to the Sun, still incredibly far away, thousands of times the distance between Earth and the Sun, its gravity, even if weak, would be enough to disturb the delicate balance of a region known as the Oort Cloud. We will talk more about this cloud later, but for now imagine it as a gigantic spherical shell surrounding our entire solar system, made of billions of fragments of ice and rock, frozen relics from the time of creation. They drift there in deep slumber, in slow and unstable orbits. When Nemesis passes through this region, it would be like someone stirring the surface of a calm lake. Its passage would create gravitational ripples, small nudges that destabilize these sleeping bodies. The theoretical result of this visit would be a rain of comets. Celestial objects that once wandered peacefully would be thrown toward the inner solar system, crossing the orbits of the giant planets, passing by Jupiter and Saturn, until eventually reaching the inner regions where Earth and Mars orbit the Sun. It is this connection between a distant star and the fate of life on Earth that makes the Nemesis theory so powerful. It ties the deep sky to our biological history. It suggests that the great extinctions, the moments when life on Earth nearly vanished before rising again in new forms, may not have been random accidents, but the ticking of a cosmic clock marked by the passage of this dark sibling. This idea transforms our view of the universe. We stop being an isolated and secure system and become part of a binary mechanism, a complex celestial machine operating in cycles of destruction and creation. The evil attributed to Nemesis is, in truth, simply physics in motion, the law of gravity exerting its influence across the vast abysses of space. It is a perspective that makes us feel small, yet deeply connected to the whole. It shows that what happens light years away in the cold darkness where our sun appears as just another star may have shaped the very fact that we are here today. As we contemplate this possibility, we are invited to look at the darkness between the stars not as emptiness, but as a place where immense things might be hidden. The sun's solitude may be only an illusion of perspective, a consequence of our limited viewpoint. Perhaps somewhere out there, our twin continues its eternal patrol, carrying the secrets of our past, and perhaps of our future. It is a thought that calms us through its sheer grandeur. To know that we are part of a dance so ancient and so vast lifts the burden of immediacy from our shoulders. It places us in harmony with the time of the stars where everything is slow, cyclical, and inevitable. And so our journey begins, following the invisible trail of this hypothetical giant, trying to understand where it might be and how its existence would change everything we think we know about our place in the cosmos. When we lie down at night and let our eyes wander through the window toward the sky, we are often overcome by a deep sense of permanence. The constellations seem painted permanently onto the black velvet of space. The Southern Cross points the way with the same reliability that once guided navigators centuries ago. The three stars of Orion's belt shimmer with a reassuring steadiness, as if they were old friends always waiting in the same place, watching over our sleep. To human experience, the sky feels eternal, a still painting where change is rare and slow. We go through our daily routines, waking, working, loving, resting, beneath this dome that seems unchanging. Yet this calm is a gentle illusion, created by the brevity of our lives. If we could speed up the film of the universe's history, we would see that the sky is not a static painting. but a powerful and restless river. Stars are born, migrate, and die. Galaxies collide and merge in a dance of unimaginable scale. And closer to home, within our own cosmic neighborhood, there is an invisible routine, a cycle of motion so vast that it escapes immediate perception, yet quietly sets the rhythm of life on our planet. It is within this hidden routine that the idea of the sun's dark twin finds its place, not as a sudden monster appearing from nowhere, but as one of the gears of a much larger cosmic clock. The experience of this phenomenon does not unfold in days, months, or years, but in eras. Imagine that the solar system has a breath, an inhale and an exhale that each last millions of years. Our everyday lives happen in the tiny pauses between these immense motions. We live in the calm, but Earth, with its memory of stone and rock, remembers the other moments as well. If we look downward, to the ground beneath our feet, and read the geological layers like pages of an ancient book, we find the signature of this cosmic rhythm. When scientists began studying fossil records in detail, they noticed something extraordinary. Extinction is not entirely random. It has a pulse. It has a rhythm. Roughly every 26 to 30 million years, life on Earth experiences a profound disturbance. Entire species disappear, ecosystems are reset, and new forms of life rise to fill the empty spaces. It is as if a cosmic winter returns again and again, sweeping the stage clean for a new season. This regularity is too precise to be pure coincidence. It suggests an astronomical cause, something that orbits, something that comes and goes with the regularity of a giant pendulum. Here is where the rhythm of Nemesis intertwines with our own. While the sun travels through the galaxy carrying its planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, in relatively stable and circular orbits, its hypothetical sibling would live a completely different existence. The life of that twin star would be defined by solitude. Its path would follow an extremely elongated elliptical orbit, taking it to the most distant and desolate boundaries of the sun's domain. To imagine where this star might live, we must stretch our minds far beyond the orbit of Pluto. Much farther still, imagine drifting away from Earth. The moon fades behind you, small and silver. Mars becomes a distant red dot. Jupiter and its magnificent bands fall away into the darkness. You pass through the Kuiper Belt, where Pluto and other dwarf planets wander in the cold. But the journey does not end there. You keep traveling outward, deeper into the blackness until the sun itself looks like just another bright star without warmth. In that remote region, nearly a light year from the center of our system, we enter the theoretical domain of Nemesis, the Oort Cloud. This structure is one of the most mysterious features of the solar system. Imagine an immense bubble, a spherical shell surrounding the entire sun, composed of trillions of objects made of ice, dust, and rock. These are sleeping comets. They have remained there since the formation of the solar system 4.5 billion years ago, preserved in the absolute cold of space, drifting in fragile balance, almost motionless. The Oort Cloud can be thought of as the solar system's winter garden, a place of deep silence and endless darkness. And it is through this frozen garden that Nemesis would make its solitary journey. For most of its orbit, it would be far too distant to disturb anything. It would simply wander through the void like any other faint star, harmless and remote. But as its orbit slowly carries it back toward its closest approach to the sun, its presence would begin to be felt, not as a violent collision, not as a sudden explosion, but as a subtle influence, a gravitational touch. Imagine a massive ship moving through a calm ocean filled with small boats drifting on the surface. The ship does not need to strike the boats to move them. Its passage alone displaces the water and creates waves that rock everything nearby. In the same way, Nemesis, passing through the dense population of the Oort Cloud, would disturb the delicate orbits of countless comets. An equilibrium that lasted millions of years would be broken. Some of those icy bodies would be flung outward, escaping forever into interstellar space. But others, perhaps millions, would be nudged inward, toward the warmth of the sun. And so a slow migration would begin. These comets would embark on journeys lasting thousands of years, gradually falling toward the inner solar system. From Earth's perspective, nothing would appear to change at first. The sky would still look calm and familiar, but the mechanism would already be in motion. The distant passage of our stellar sibling would have left behind a delayed gift. This is the hidden experience of our solar system. We live in what feels like a protected environment, shielded by the giant planets such as Jupiter, which often act as cosmic guardians, capturing many wandering asteroids and comets. Yet the idea of Nemesis reminds us that this safety may be temporary. There may be seasons of storms written into the very mechanics of our system. There could be moments in the grand routine of the cosmos when the sky becomes more dangerous, when falling stars cease to be only poetic wishes and become messengers of transformation. It is fascinating to consider that our own existence may be tied to this cycle. If the dinosaurs had not vanished 66 million years ago, in an event that fits remarkably well within the proposed timing of the Nemesis cycle, mammals, our direct ancestors, might never have had the opportunity to leave their burrows and eventually dominate the planet. The shadow of Nemesis, then, would not bring only endings. It would also bring beginnings. The routine of this so-called evil twin would paradoxically be a routine of creation. It would prune the tree of life, allowing new branches to grow in unexpected directions. When we look at the night sky now, perhaps we can feel an added layer of depth. The darkness between the stars is not empty. It may be the stage for an orbit that takes millions of years to complete. While we sleep, while Earth slowly turns on its axis, we are traveling, not only around the sun but along with it through this immense celestial dance. At this very moment we occupy some point along that great ellipse. Perhaps we are living in a time of calm, a cosmic summer far from the influence of the distant red dwarf. Or perhaps we are slowly approaching the moment when the pendulum swings back again. But there is no need for immediate fear. The timescales we are speaking of are far beyond human concerns. 1,000,000 years is a heartbeat for the universe, but an eternity for us. The rhythm of Nemesis is slow, majestic, and logical in its own quiet way. It teaches us patience. It reminds us that we are part of a living and dynamic system. Earth is not an isolated island. It is a vessel sailing through an ocean where the tides are made of gravity, and the waves are made of comets. And the lighthouse that guides or confuses this voyage may be our own distant sibling, the star that was born with the sun, and that, even unseen, may never have fully left us. Now that we understand the vast gravitational waltz that may be unfolding at the borders of our solar system, we need to descend into deeper details. We must step behind the curtain of this celestial machinery and ask a fundamental question. If there truly is a sibling star, so close in astronomical terms, and potentially so influential to our fate, why have our eyes never found it? How could a massive object, capable of throwing comets through the darkness and shaking life on Earth, remain hidden from all of our telescopes and space probes? The answer to this mystery lies in the subtle nature of light and in the deceptive immensity of empty space. To understand the invisibility of Nemesis, we first need to abandon the image we usually have of a star. When we think about a star, we almost always imagine something like the sun, a blazing sphere of white or golden plasma, radiating intense light and heat. But the universe is a place of extraordinary diversity. Stars exist in many sizes, temperatures, and colors. In fact, most stars in our galaxy are nothing like the sun. They are smaller, cooler, dimmer, and far more discrete. Scientists believe that if Nemesis exists, it likely belongs to a class of celestial bodies that live in the shadows. The main candidates for its identity are red dwarfs or brown dwarfs. Let us imagine what that means. A red dwarf is a star that burns its nuclear fuel very slowly, almost reluctantly. It is small, sometimes only a third of the sun's mass, and its surface is far cooler than the blazing furnace of our star. It does shine, but its light is faint and reddish, more like the soft glow of embers in a fireplace than the bright flame of a torch. If our human eyes were close to a red dwarf, the world around it would appear bathed in a dim crimson twilight, a quiet and subdued light that never quite becomes day. But there is an even more elusive possibility. Nemesis might not be a true star at all. It could be a brown dwarf. Brown dwarfs are among the most mysterious objects in astronomy. They live in a strange gray zone between planets and stars. Many astronomers call them failed stars. Imagine a body that tried to become a star. It gathered gas and dust, it grew large and massive, but it never quite reached the critical mass required to ignite sustained hydrogen fusion in its core. It almost became a star, but not quite. Instead of blazing with visible light, a brown dwarf emits mostly heat. It shines primarily in the infrared part of the spectrum, light that human eyes cannot see. In the cold emptiness of space, such an object would be almost ghost-like. a dark body moving through an already dark background. Searching for a brown dwarf in deep space is like trying to find a piece of charcoal in a vast dark room, miles away from where you stand. The object is there. It has mass. It has gravity. But visually, it refuses to reveal itself. This shy, dim nature would allow Nemesis to remain hidden for billions of years, camouflaged within the darkness that surrounds it. Yet invisibility is not the only reason we might have missed it. Distance and motion also play a role in this cosmic game of hide and seek. Space has depth, but when we look at the night sky, we lose the sense of that depth. A star 10 light-years away, and another 1,000 light-years away, appear as similar points of light on the same flat canvas of darkness. To identify Nemesis, astronomers would need to detect its movement. Distant stars appear fixed because they are unimaginably far away, but a nearby object orbiting the sun would move slowly against the background of those distant stars. Astronomers call this proper motion, or parallax. If Nemesis exists, it should slowly drift across the sky over many years. But here again we encounter the enormous scale of time. Its orbit may take 26 million years to complete. From Earth, that movement would be incredibly subtle. Detecting it would require extremely precise maps of the sky, taken years apart, comparing the position of millions of faint objects until one tiny red point is seen to shift slightly relative to the others, and the sky is filled with countless red and brown dwarfs. Distinguishing which one might be our hidden sibling is like searching for one particular grain of sand on a beach, made entirely of identical grains. To understand where such a body might hide, we must return once again to the Oort Cloud, but now with a more careful look at its structure. The Oort Cloud is not a ring. It is a sphere, a gigantic shell that surrounds the solar system in every direction, like the outer surface of an enormous cosmic egg. Its scale is almost impossible to grasp. It begins far beyond Pluto and stretches outward to distances approaching half the distance to the nearest star. Astronomers estimate it may extend up to 100,000 astronomical units from the Sun. An astronomical unit is the distance between Earth and the Sun. Sunlight takes about 8 minutes to travel that distance, but to reach the outer edge of the Oort Cloud, sunlight would travel for nearly 2 years. In that remote and silent region, the mechanism behind periodic extinctions may be triggered. Gravity weakens with distance, but it never disappears completely. When Nemesis approaches the inner edge of this distant region, its gravitational pull would act like a tide. Just as the moon raises tides in Earth's oceans, Nemesis could raise gravitational tides within the Oort Cloud. Billions of frozen objects drift there in fragile equilibrium. A small disturbance would be enough. A gentle gravitational tug could change their speeds and alter their orbits. Orbital mechanics tells us that when the velocity of an orbiting body changes, even slightly, its trajectory changes as well. Some comets would be flung outward into interstellar space, lost forever. Others would spiral inward toward the sun. And suddenly, the inner solar system, the region where Earth resides, would become a much busier place. The chance of impacts would increase dramatically. Not a single night of meteor showers, but an entire era of celestial instability. For hundreds of thousands of years, comets might cross the sky more frequently, some captured by Jupiter, others colliding with planets. Eventually, the disturbance would fade as Nemesis moved away again, and calm would return. But the echoes of that passage would remain carved into the geological memory of Earth. What is particularly fascinating is how this idea first emerged. It did not originate from looking at the sky. It came from studying the Earth itself. In the 1980s, two paleontologists, David Raup and Jack Sepkoski, analyzed a vast record of marine fossils spanning more than 250 million years. They were not searching for stars. They were searching for patterns in extinction. And what they discovered was astonishing. Extinctions seem to occur in cycles. Roughly every 26 million years, the fossil record showed a spike in the disappearance of species. The statistical signal was strong enough that it demanded an explanation. No purely geological process, volcanoes, climate change, sea level fluctuations, appeared capable of maintaining such a precise rhythm for hundreds of millions of years. But celestial mechanics could. Orbital motion is one of the most reliable clocks in nature. And so the hypothesis of Nemesis emerged. Not from observation, but from necessity. The star was imagined first in equations before anyone ever tried to see it. It became a theoretical companion to explain the pulse of life and death recorded in Earth's rocks. Today, the search continues with increasingly sophisticated tools. Space telescopes that can see infrared heat, such as the WISE Observatory, have scanned the entire sky searching for brown dwarfs near our solar system. So far, no clear sign of Nemesis has appeared. Some scientists interpret this absence as evidence that the star does not exist. Others argue that it could still be hiding. Perhaps it lies in a region of the sky difficult to observe. Perhaps it is even colder and darker than expected. Or perhaps it blends into the dense glow of the Milky Way's galactic plane, where billions of stars make it difficult to distinguish faint nearby objects. Absence of evidence is not evidence of absence. The physics still allows such an object to exist. The geological record still hints at periodic disturbances, and the vastness of space leaves countless hiding places. Nemesis reminds us of something humbling. Even with our advanced technology, our map of the universe still contains enormous blank spaces. There are still regions of mystery where unseen giants may quietly drift. While we listen for the faint echoes of that distant twin, we learn something deeper about our own world. Life on Earth has survived repeated cosmic winters. Again and again it has adapted, evolved, and returned stronger. Perhaps that is the true lesson hidden in this mystery. The universe is not static. It is dynamic, rhythmic, and alive with motion. And somewhere in the deep cold where sunlight is only a distant memory, a faint ember may still circle slowly around our sun, silently shaping the history of our planet. If the existence of Nemesis were a trial in a cosmic courtroom, the evidence would not come in the form of videos or eyewitnesses, but rather in footprints left in the deep snow of space and in ancient scars etched into the skin of our planet. This is where our story turns into a kind of investigation. We become detectives of the invisible, gathering fragments of a mystery that has challenged astronomers for decades. We are not speaking only of abstract ideas, but of real anomalies, objects that appear where they should not be, and celestial behaviors that make little sense unless there is an unseen conductor guiding the orchestra. One of the greatest secrets the solar system kept for most of human history, and one that only recently began whispering to us, goes by the name Sedna. The discovery of this distant world in 2003 shook the scientific community. Sedna is not a typical planet, nor is it an ordinary comet. It is a planetoid, a cold reddish body made of rock and ice, living in an exile so remote that it challenges our imagination. What makes Sedna mysterious is not only what it is, but where it is, and how it moves. To understand the strangeness of Sedna, imagine the orbit of Earth as a circle close to a campfire. The orbit of Pluto, already far away, would be another circle far out in the shadows. Sedna's orbit goes far beyond that simple scale. Its path is so stretched, so elongated, that it takes more than 11,000 years to complete a single trip around the Sun. At its most distant point, Sedna travels so far away that the Sun appears merely as a bright star in a very dark sky. The great question, the puzzle that keeps astrophysicists awake at night, is this: how did Sedna end up there? The gravity of the Sun alone cannot easily explain such an extreme and isolated orbit. Sedna never comes close enough to the giant planets like Jupiter or Neptune to have been gravitationally kicked outward by them, but it also never travels far enough to have been captured by passing stars. It exists in a kind of celestial no-man's land. Its orbit suggests that something massive once passed nearby, something with enough gravitational influence to pull Sedna away from its original birthplace and cast it into this lonely trajectory. Could it have been a passing star that brushed past the young solar system billions of years ago and then continued on its way? Perhaps, but the orbits of Sedna and several other recently discovered distant objects hint at something more persistent, something that might still be out there today. These distant bodies appear strangely aligned, as if their orbits were gently shepherded by an invisible hand. That unseen shepherd could be our mysterious twin. For many astronomers, Sedna represents something like a fingerprint left at the scene of the crime, a silent clue suggesting that the solar system may not be alone in its outermost territories. Yet the secrets do not remain only in distant orbits. They also appear closer to home, hidden within the scars of Earth itself. Another intriguing line of evidence connected to the Nemesis idea comes from the study of impact craters. Although wind, water, and geological activity slowly erase many of these marks, our planet still carries the memory of ancient bombardments. When scientists mapped the ages of large impact craters on Earth, something curious appeared. That same rhythm, that same pulse. Just as the fossil record hinted, the record of impacts seemed to show clusters, periods when collisions happened more frequently, followed by long, quiet intervals. But there is an even subtler detail hidden within this pattern. Some studies suggest that these impacts did not occur in a single catastrophic moment, but rather in waves, extended periods lasting hundreds of thousands or even millions of years. This is exactly what we would expect if a distant star were disturbing the Oort Cloud. It would not create a single event. It would create a season of instability. During such a period, the skies of Earth might grow gradually more dangerous, as if the cosmos itself had begun stirring. Geology, in this way, becomes an unexpected ally of astronomy. The rocks beneath our feet preserve traces of motions happening billions of kilometers away. But if the indirect evidence is intriguing, the direct search for Nemesis has produced its own mysteries and frustrations. One of the most ambitious hunts took place with a spacecraft known as WISE, the Wide Field Infrared Survey Explorer. This infrared space telescope was launched by NASA with a mission to scan the entire sky, looking specifically for faint objects that emit heat rather than visible light. WISE was an ideal hunter for brown dwarfs. Even if Nemesis were invisible to optical telescopes, its faint warmth might still betray its presence. The spacecraft mapped hundreds of millions of objects, discovering thousands of new asteroids and distant stars. Yet when astronomers carefully analyzed the data, Nemesis did not appear. At first glance, that seemed like a disappointing result. But in science, even an absence can be revealing. The failure to find Nemesis in those observations does not necessarily mean that it does not exist. Instead, it tells us that if Nemesis is real, it must be even more subtle than expected. Perhaps it is colder. Perhaps it is smaller. Perhaps its orbit carries it much farther away than the early models predicted. Or perhaps it hides within a region of the sky crowded with countless stars, such as the bright band of the Milky Way itself, where distinguishing faint nearby objects becomes incredibly difficult. There is also another possibility. What if our mysterious companion is not a star at all? Some astronomers have suggested that the hidden mass influencing these distant objects might instead be a giant planet, a world far larger than Jupiter, but smaller than a star. This idea has appeared in several variations over time, sometimes under names like Tyche or the now famous Planet 9. Although Planet 9 is technically a separate hypothesis, it shares the same underlying clue. The motions of distant objects in the outer solar system suggest that some unseen mass may still be shaping their paths. Gravity rarely lies. If objects move in unusual ways, something must be pulling them. Where there is motion, there is mass. Where there is a dance, there must be a partner. Another fascinating piece of this puzzle comes from the discovery of wandering stars and planets drifting through interstellar space. Astronomers now know that the galaxy contains many orphan worlds, planets and stars that were ejected from their birth systems and now travel alone through the darkness between the stars. This raises an intriguing possibility. What if Nemesis is not truly our sibling by birth? What if it is an adopted companion? Imagine the sun moving through the galaxy and capturing a wandering star that happened to pass nearby long ago. Or imagine the opposite scenario, that the sun once had a twin, born from the same nebula, but the fragile gravitational bond between them eventually broke. In stellar nurseries, wide binary systems, pairs of stars separated by enormous distances, are often unstable. The gravitational pull of passing stars or the tides of the galaxy itself can tear them apart. Perhaps Nemesis once existed and influenced the early solar system, only to drift away billions of years ago. In that case, we might be living in the quiet aftermath of a relationship that ended long ago. But if that were true, it would not easily explain the continuing periodic rhythm of extinctions. That is why many researchers still suspect that the companion, if it exists, is still out there. Hidden, distant, patiently circling. One rarely discussed aspect of this mystery touches on a concept in astrobiology known as the Great Filter. Scientists often wonder why we have not yet encountered intelligent civilizations elsewhere in the galaxy. One possibility is that life frequently struggles to survive long enough to become complex. Cosmic catastrophes may repeatedly reset the evolutionary clock. Yet the Nemesis theory offers a curious twist on that idea. Perhaps these cycles of destruction are not only obstacles, Perhaps they are catalysts. Without mass extinctions, evolution might stagnate. Dinosaurs ruled the Earth for more than 150 million years without developing advanced intelligence or technology. It was only after their disappearance, possibly triggered by an impact event, that mammals had the chance to expand, diversify, and eventually give rise to us. From that perspective, Nemesis would not be a villain. It would be a harsh gardener, pruning the tree of life so that new branches can grow. Today, the search continues. New telescopes, new surveys, and new computational tools are constantly refining our view of the outer solar system. Future observatories like the James Webb Space Telescope and the Vera Rubin Observatory will look deeper into the darkness than ever before. Perhaps one day a faint red glow will appear in the data, a tiny wandering ember revealing the presence of a hidden star. Or perhaps the mystery will remain unsolved. Either way, the search itself has already transformed our understanding. It has shown us that the solar system is far larger, more complex and more mysterious than we once imagined. And somewhere, far beyond Pluto, Sedna continues its lonely journey, circling slowly in the frozen twilight of the outer solar system, a silent witness, guarding a secret that we are still trying to understand. So far, we have followed the trail of a single hypothetical star, a lost sibling orbiting our sun in distant silence. But to truly grasp the magnitude of this story, we must widen our horizon even further. The solar system is not a sealed bubble, isolated from the rest of the universe. It is a traveler connected to a far greater web of forces, influences, and rhythms. The theory of Nemesis, whether it ultimately proves correct or not, opened a crucial door in our understanding. The realization that Earth is deeply connected to the cosmos, and that the destiny of life here may be shaped by gravitational tides far beyond our immediate neighborhood. Now we explore those invisible connections. We will see how the dance of Nemesis may be synchronized with the breathing of the galaxy itself, and how stones that fall from the sky can shape not only landscapes, but the very biology of the beings who inhabit this blue world. To begin expanding this perspective, imagine the sun not as the center of everything, but as a small boat navigating the vast ocean of the Milky Way. Our galaxy is a gigantic spiral, a rotating disk of stars, gas, and dust, turning majestically through the darkness. The sun, carrying Earth and the other planets along with it, travels around the galactic center. But this journey is not a perfect circle on a flat plane. It is more like a wave. Picture a carousel. While the horses rotate around the center, they also rise and fall. The sun behaves in a similar way, as it orbits the supermassive black hole at the center of the Milky Way, a journey that takes about 250 million years. We also move up and down through the galactic plane. The galactic plane is the dense middle layer of the galaxy, where most of the stars and gas clouds reside. And here we encounter a fascinating connection that sometimes competes with and sometimes complements the idea of Nemesis. Scientists noticed that the extinction cycle on Earth, the rhythm of roughly 26 to 30 million years, coincides curiously with the times when the solar system passes through this denser region of the galaxy. This coincidence raises a profound possibility. What if the evil twin is not a star at all? What if the culprit is the galaxy itself? The mechanism would work like this. As the sun plunges through the galactic disk, it enters a region where gravity is stronger due to the presence of many nearby stars and gas clouds. This combined gravitational influence creates what astronomers call a galactic tide. That tide can disturb the Oort Cloud. In much the same way that Nemesis might, the gravitational pull of the galaxy could destabilize comets and send them drifting toward the inner solar system. This idea connects our fate to an even grander scale. It suggests that events such as the extinction of the dinosaurs or the rise of mammals may have been influenced simply by the solar system traveling through a more crowded neighborhood of the Milky Way. Our cosmic address changes over time, and with it, the risks and opportunities change as well. If Nemesis does exist, its orbit could be influenced by this galactic motion, creating a clock within a clock, a smaller mechanism turning inside a much larger one. But the connections between the cosmos and life on Earth go even deeper. They reach into the chemistry of life itself. Let us think about what actually happens when a comet or asteroid strikes our planet. These objects do not carry only destruction, they also carry ingredients. Comets are ancient capsules made of ice, dust, and complex organic molecules, the basic building blocks of life. There is a scientific idea called panspermia, which proposes that life, or at least the chemical seeds of life, may have arrived on Earth aboard these cosmic messengers. If that is true, then the disturbances of the Oort Cloud, whether caused by Nemesis or by galactic tides, may not only bring devastation, they may also bring renewal. Imagine a distant star stirring the cloud of frozen comets and sending them inward. Some of those icy travelers could deliver water. Others could carry carbon-based molecules. Over billions of years, these deliveries may have helped shape the chemistry of our oceans and the emergence of life itself. In this sense, the connection becomes intimate. The atoms in our bodies, the carbon in our cells, the water in our blood, may have once traveled across the dark frontier of the solar system before falling gently onto the young Earth. And so destruction and creation become intertwined. Large impacts also reshape the climate of our planet. When a massive asteroid strikes, dust rises into the atmosphere and blocks sunlight. Temperatures fall. Photosynthesis collapses. Food chains break apart. Then, after the dust settles, greenhouse gases released by the impact can warm the planet dramatically. These violent swings force life to adapt. Evolution, as we now understand, does not always move slowly and smoothly. Instead, it often unfolds through long periods of stability, interrupted by sudden upheaval. The paleontologist Stephen Jay Gould described this pattern as punctuated equilibrium, long stretches of calm, then bursts of transformation. And what punctuates that equilibrium? Often it is the cosmos itself. If Nemesis truly exists, then it may be one of the metronomes of evolution, setting the tempo of catastrophe and innovation. Consider our earliest mammalian ancestors. For millions of years, they lived in the shadows of giant reptiles, small nocturnal creatures hiding in burrows. If the great cosmic balance had never been disrupted, if the dinosaurs had continued ruling the Earth uninterrupted, it is very possible that mammals would have remained minor players in the ecological drama of the planet. Human intelligence itself may therefore be a distant consequence of that ancient catastrophe. We are, in a sense, the children of cosmic accidents. This perspective also reshapes how we think about protection. Jupiter is often described as Earth's guardian, the massive gas giant whose gravity captures many incoming asteroids and comets. But the story becomes more complex in a disturbed solar system. During times of calm, Jupiter acts as a shield. But during periods when the Oort Cloud is shaken, even Jupiter can become part of the mechanism, redirecting comets toward the inner solar system as easily as it deflects them away. The solar system is not a simple machine with heroes and villains. It is a delicate balance of forces. Everything interacts. Nothing acts alone. The Earth itself preserves the memory of these interactions. The famous iridium layer marking the boundary between the Cretaceous and Paleogene periods, the moment when the dinosaurs vanished, is made of material rarely found in Earth's crust but common in asteroids. That thin layer of metal-rich dust is, quite literally, stardust, a piece of the sky embedded in the ground beneath our feet. When we touch such rocks, we are touching the residue of events that began far beyond our planet. But these connections also extend into the future. If the cycles we observe are real, then they will continue. Another disturbance will eventually occur. Another wave of comets will someday sweep through the inner solar system. This realization changes our perspective. History is no longer a straight line of endless progress. It becomes a moment of opportunity inside a much larger cycle. But there is a difference today. For the first time in Earth's history, a species exists that can understand the danger and perhaps respond to it. If we detect a comet on a collision course decades or centuries in advance, we may be able to deflect it. Humanity could become something new, not just a product of cosmic forces, but a guardian against them. In that sense, intelligence may serve as the immune system of the planet. Life evolved through chaos, but now, life may learn to defend itself from it. This realization adds a profound layer of meaning to our place in the universe. We are not merely passengers on a fragile rock drifting through space. We are participants in a vast cosmic ecology. The gravity that moves distant stars is the same force that holds oceans to the Earth and keeps our feet gently pressed to the ground. Everything is connected. Astronomy explains geology. Geology explains biology. Biology explains our own story. And through that chain of understanding, the mysterious possibility of a distant twin star becomes something more than speculation. It becomes a thread that stitches together the sciences of the cosmos and the story of life. a reminder that the universe is not distant from us. It lives within us. And while we rest beneath the quiet sky tonight, the same gravity that may guide a hidden star through the far edges of the solar system is also holding our world gently in place. A slow and eternal dance, one that continues, whether we are awake to witness it or peacefully asleep beneath the stars. Throughout this journey, we looked at the stars, the rocks, and the fossils. Now it is time to turn the mirror toward ourselves. How does the idea of a twin sun, an invisible companion that may quietly influence the rhythm of life and death, resonate within the human mind? The relationship between humanity and the cosmos has never been purely scientific. It has always been emotional, philosophical, and deeply personal. The sky above us is not only a place of distant lights, it is a mirror in which we project our fears, our hopes, and our endless search for meaning. Since the earliest humans first lifted their eyes toward the night sky, we have felt a strange mixture of wonder and unease. The darkness above once seemed to be the domain of gods, spirits, and forces far beyond human control. In many ways, the idea of Nemesis is the modern scientific echo of those ancient myths. It touches something deep within our collective psyche, the quiet awareness that we are not entirely in control, that there are cycles and forces far larger than us shaping the world in ways we barely understand. Consider the ancient civilizations that studied the heavens with such devotion: the Maya, the Babylonians, the Egyptians. Each of them constructed elaborate calendars, carefully tracking the movements of stars and planets. These calendars were not only tools for agriculture or navigation, they were attempts to read the moods of the sky. To them, a comet was never just a chunk of ice reflecting sunlight. It was a messenger, a sign, a warning. Across many cultures, the sudden appearance of a comet was believed to signal great change, the fall of kings, the birth of new eras, or the arrival of catastrophe. Today we understand that these comets may have been travelers from the outer solar system, disturbed by gravitational forces we are only now beginning to map. What ancient people interpreted as divine messages may simply have been the distant mechanics of celestial motion. There is something poetic about that realization. Our ancestors sensed the danger without knowing the physics behind it. They felt that the sky had the power to change the course of life on Earth, and in a sense, they were right. Modern science has not erased that intuition. It has transformed it. What once appeared to be divine intervention is now understood as orbital dynamics. Where rituals once tried to appease the heavens, mathematics now allows us to predict them. This transformation, from fear to understanding, is one of humanity's greatest achievements. But the relationship goes deeper than fear. There is also a quiet sense of companionship hidden in the idea of Nemesis. For a long time, humanity has felt somewhat alone in the universe. We look at the vast darkness between the stars and ask a simple question: why are we here? Are we alone? The possibility that the sun itself might have a distant companion star carries an unexpected emotional resonance. It suggests that our solar system may not be solitary after all, that even our star could have a sibling. There is something strangely comforting about that thought. Even if that sibling is distant and mysterious, its existence would mean that our cosmic home is part of a pair. We would no longer be the lonely exception in a galaxy where most stars are born with companions. In a quiet way, the story of Nemesis mirrors a familiar human experience. Discovering a relative we never knew we had. Learning that our family is larger than we imagined. Even if that relative lives far away and visits rarely, their existence fills in a missing piece of the story. At the same time, this theory invites us to confront humility. Human civilization, our cities, our histories, our technologies, occupies only the smallest fraction of cosmic time. All of recorded history, from the earliest written symbols to modern science, fits comfortably within a period of orbital calm. We have been living during a peaceful chapter, a cosmic summer. The idea of Nemesis reminds us that such stability may not last forever. The calm we enjoy today may simply be the quiet interval between larger movements in the machinery of the universe. And yet, rather than inspiring fear, this realization can inspire unity. If humanity truly accepts that we are passengers together on a small and fragile world, one that occasionally faces dangers from the sky, then many of our divisions begin to lose their importance. Borders become imaginary, political disputes become temporary, cultural differences fade in significance. From the perspective of a 10-kilometer asteroid traveling through space, there are no nations. There is only one planet, one fragile biosphere, and one species capable of understanding the threat. This awareness is already beginning to shape our future. The field known as planetary defense has emerged in recent decades as scientists and space agencies collaborate to monitor near-Earth objects. Telescopes scan the skies, computers calculate trajectories, and missions are being designed to test whether we can alter the course of dangerous asteroids. For the first time in the history of life on Earth, a species has developed the ability to recognize cosmic hazards, and perhaps to prevent them. In that sense, humanity may become something extraordinary, the immune system of the planet. Life evolved under the pressure of cosmic uncertainty, but intelligence gives life the ability to respond. The theory of Nemesis also changes how we think about time. Most human concerns unfold within short horizons, days, years, or decades. We worry about tomorrow's tasks, next year's economy, the political cycles of our generation. Astronomy invites us to expand our perspective. When we talk about cycles of 26 million years, our sense of urgency dissolves. Such timescales are vast beyond comprehension. Yet thinking about them can be strangely calming. It reminds us that change is the natural state of the universe. Mountains rise and erode. Species appear and disappear. Stars are born and fade away. Everything flows through cycles. From that perspective, our worries shrink. Our lives become brief but meaningful moments within a much larger story. Culturally, Nemesis has already begun to appear in our imagination. Films, novels, and speculative stories often portray hidden stars or unseen cosmic threats. These narratives reflect an ancient archetype, the idea of a silent force lurking in the shadows. Yet unlike the villains of fiction, Nemesis would not be malicious. Stars have no intention, no anger, no plan. They simply follow gravity. And that indifference is what makes the cosmos so majestic. The universe is not against us. It is not for us either. It simply unfolds according to its laws. And within that unfolding, life emerged, and eventually, consciousness. We are the moment when the universe became aware of itself. The search for Nemesis also reflects a deeper human impulse: curiosity. Why do we spend decades and enormous resources searching for a faint star trillions of kilometers away? Because unanswered questions are irresistible. Human beings are explorers. We cannot tolerate blank spaces on the map. As long as there is a shadow in the outer solar system, someone will try to shine a light into it. This relentless curiosity is the engine of science. It transforms uncertainty into knowledge. It turns fear into understanding. And perhaps most importantly, it reminds us that the story of the universe is not finished. There is still so much left to discover. Even if Nemesis is never found, the search itself has already changed us. It has pushed us to map the solar system with extraordinary precision. It has deepened our understanding of stellar formation. It has connected astronomy with geology, biology, and the history of life. In that sense, the journey has value regardless of the final answer. Perhaps the greatest lesson is philosophical. Destruction and creation are not opposites in the cosmos. They are partners. Mass extinctions open the door for new forms of life. Chaos creates opportunity. The universe is not static. It is a garden that occasionally prunes itself. And in that garden, humanity has emerged as a species capable of reflection, of curiosity, of wonder. As you close your eyes tonight, imagine humanity as a family of quiet observers scattered across a small blue world. We are passengers together on a spinning sphere of rock and ocean. Above us stretches a sky filled with mysteries. Some of those mysteries may hold danger. Many hold beauty. But the greatest miracle is that we are here to contemplate them, to tell their stories, to look outward and inward at the same time. And in that silent exchange between the human mind and the light of distant stars, we begin to understand our place in the universe. Small, fragile, but capable of infinite wonder. As we look toward the horizon of time, toward the years and centuries stretching ahead of us, the search for Nemesis stops being merely an investigation of the past and begins to feel like a key to the future. What began as curiosity about ancient comets and the extinction of dinosaurs has quietly transformed into one of the most fascinating frontiers of modern astronomy. We are entering a new golden age of space exploration. The tools we are building are not only allowing us to see farther into the universe, but also to see with a level of clarity and depth that earlier generations of scientists could hardly imagine. The future of this mystery will not be written only in theory. It will be written by the telescopes we point toward the sky. For centuries, astronomy relied on snapshots of the universe. Observers captured a moment of the sky and studied that frozen image. But Nemesis, if it exists, would not reveal itself in a single photograph. Its signature would be motion. A faint object slowly drifting against the background of distant stars. To find it, astronomers must do more than photograph the sky. They must record its story over time. And this is exactly what the next generation of observatories will do. One of the most important of these instruments is the Vera C. Rubin Observatory, located high in the dry mountains of Chile. This facility is not simply another telescope. It is designed to watch the entire sky again and again, night after night, year after year. At the heart of the observatory is one of the most powerful digital cameras ever built. Its resolution is so extraordinary that it could detect a golf ball sitting on the surface of the moon. Every evening, the Rubin Observatory will sweep across the southern sky, building an enormous and constantly evolving map of the universe. This project is called the Legacy Survey of Space and Time. Over the course of 10 years, it will create something humanity has never had before. A living, dynamic record of the changing sky. Billions of celestial objects will be cataloged. Stars, galaxies, asteroids, comets, and perhaps, hidden among them, something that moves just a little differently. Something faint, something slow, something that does not quite belong among the distant stars. If Nemesis is a dim red dwarf or an ancient brown dwarf slowly drifting through the outskirts of our system, the Rubin Observatory may finally reveal it, because it will not only see light, it will see movement. Even the tiniest shift in position across the sky can betray the presence of a nearby object. And here the story becomes even more remarkable. The volume of information produced by this observatory will be enormous, far beyond what human astronomers could analyze alone. Every night, vast rivers of data will flow from the telescope's detectors, petabytes of information, images of the sky repeated again and again. To search through this cosmic archive, scientists will rely on artificial intelligence. Algorithms will quietly examine millions of stars and faint points of light, comparing their positions across time, looking for patterns, looking for movement, looking for anomalies. Perhaps one day, in a quiet laboratory somewhere, a computer will raise an alert. A faint red point has shifted. A tiny ember of heat has moved slightly against the cosmic background. And suddenly, after decades of speculation, the hidden companion of the sun might finally reveal itself. If that moment comes, the consequences will ripple through both science and culture. Textbooks would change. The solar system would no longer be considered solitary. It would become officially a binary system. The sun and its distant partner would form a gravitational pair, and with that discovery would come a new question. Where are we in the cycle? By mapping the orbit of Nemesis precisely, astronomers could determine where the star currently sits in its immense journey. Are we in a quiet cosmic summer far from its influence? Or are we slowly approaching another distant encounter? Such knowledge would not bring fear. It would bring understanding. For the first time, humanity would have a calendar of cosmic risk. A timetable measured not in centuries but in millions of years. Enough time for future civilizations, human or otherwise, to prepare. Yet there is another possible future. A different ending to the mystery. What if Nemesis is never found? What if the sky is searched again and again with ever greater precision, and still no hidden star appears? In that case, the mystery would not disappear. It would deepen. The cycles of extinction would still demand explanation. Scientists would turn their attention to other possibilities. One intriguing candidate is dark matter. Some theorists propose that a thin disk of dark matter may exist within the plane of our galaxy. If such a structure exists, the solar system might pass through it periodically as it oscillates above and below the galactic plane. The gravitational influence of this invisible matter could disturb the Oort Cloud in much the same way Nemesis would. Another possibility involves a distant giant planet, sometimes called Planet 9. Such a world far beyond Neptune could shepherd the orbits of distant objects and occasionally send comets inward. In science, a negative result is never wasted. Every unanswered question pushes us to refine our models and deepen our understanding, and so the search itself becomes part of the discovery. Regardless of the outcome, humanity is also developing something new, the ability to defend our world. For billions of years, life on Earth was helpless before cosmic hazards. Asteroids struck without warning. Comets arrived unannounced. Extinctions unfolded without resistance. But that may no longer be true. In recent years, space agencies tested the first real attempt to alter the course of an asteroid. A mission called DART deliberately collided with a small asteroid to change its orbit. It was a modest experiment, but symbolically, it was enormous. For the first time in Earth's history, a species had successfully nudged a celestial object. The universe had thrown stones at Earth for billions of years. Now, Earth had learned to push back. If the disturbances of the Oort Cloud one day send a dangerous comet toward our planet, future generations may be able to intercept it, deflect it, or break it apart. The shadow of Nemesis, whether real or imagined, has inspired humanity to build a planetary shield. Fear has quietly transformed into engineering, and if we allow our imagination to travel even further into the future, the story becomes almost poetic. Billions of years from now, the sun itself will change. Like all stars of its size, it will eventually exhaust its hydrogen fuel. It will swell into a red giant, expanding outward and engulfing the inner planets. Mercury and Venus will vanish. Earth may become uninhabitable. Later, the sun will shed its outer layers and collapse into a white dwarf, a dense and fading ember. But if Nemesis is a red dwarf or a brown dwarf, its fate may be very different. Small stars burn their fuel slowly. They can shine for trillions of years. Long after the sun has faded, Nemesis might still glow faintly in the darkness. In that distant future, the roles would reverse. The quiet, dim companion, the star we once feared, might become the last remaining source of warmth in the system. Perhaps unimaginably far in the future, descendants of humanity might travel outward, leaving the cooling remains of the sun behind, seeking refuge around the faint red glow of the once mysterious companion. The star we once imagined as a bringer of destruction might one day become a final sanctuary, a distant campfire in the cold night of the universe. For now, however, we remain here, on our small blue world, looking outward. The Voyager probes have already crossed the edge of the sun's protective bubble and entered interstellar space. Future missions will travel even farther, carrying our instruments, our curiosity, and perhaps one day our presence into the distant regions where the secrets of the solar system wait. Supercomputers simulate the motions of stars and comets, replaying millions of years of celestial history to understand how our system evolved. Astronomy is becoming a hybrid science, half observation, half simulation. And somewhere in those calculations, somewhere in the quiet darkness beyond Neptune, the answer may be waiting. Perhaps Nemesis exists. Perhaps it does not, but the search itself ensures something important. We never stop exploring. We never stop asking questions. And as long as there are mysteries hidden in the darkness beyond the planets, there will always be someone looking up at the sky, wondering what waits out there. We have now reached the end of this long journey through the far edges of the solar system. After traveling through cosmic nurseries, frozen comet clouds, and the silent corridors of deep space, it is time to gently return home. The mind, which wandered so far in search of a lost sibling star, can now settle again, like a leaf drifting softly down into the quiet of a nighttime garden. The story of Nemesis, with all its mystery and grandeur, leaves us with a feeling that is both humbling and comforting at the same time, a sense of belonging. Throughout this exploration, we discovered that the universe is not a lonely place, but a web of invisible connections. The idea that the sun might have a hidden twin reminds us that nothing in the cosmos exists entirely alone. Gravity forms invisible bonds between distant bodies, guiding the movements of stars and planets across unimaginable distances. And that same force, the same quiet pull shaping the orbits of comets and stars, is also holding you gently in place right now. It is the force that keeps Earth circling the sun, the force that keeps the moon beside our planet. And in this very moment, it is the force that holds your body safely against the bed as you rest. There is something deeply calming in that realization. The laws that guide the immense machinery of the universe are the same laws that cradle us here, in this small moment of quiet. Think about the night surrounding you now. The darkness outside is not an empty void. It is a vast blanket of rest. The solar system itself has rhythms, long cycles of calm and disturbance, of quiet summers and distant cosmic winters. The theory of Nemesis teaches us that even on the scale of millions of years, the universe moves through patterns of action and renewal. And just like the universe, we also have our own cycles: wakefulness and sleep, activity and restoration. Your night is simply a small orbit within the larger dance of existence. Now there are no more puzzles to solve. Science has kept its watch for the evening, and it has brought us back safely to this quiet place. Perhaps somewhere far beyond Pluto, a faint red ember of a star truly does wander through the outer darkness. Perhaps the sun once had a companion and lost it long ago. Or perhaps the mystery itself is simply another reminder of how vast and beautiful the cosmos still is. Not every mystery needs to be solved tonight. Some mysteries are meant to accompany us like distant stars, quiet reminders that the universe is larger than our worries. If a distant twin star exists, you can imagine it now as a silent guardian at the frontier of our solar system, a patient traveler moving slowly through the dark, keeping watch over the outer boundaries while Earth sleeps peacefully within. And here on our small blue world, life continues in its gentle rhythm. Oceans breathe with the tides, forests whisper with the wind, cities grow quiet as night settles in. Above it all, the sky remains vast and patient. Billions of stars shine across the darkness, each one part of a story that began long before humanity ever opened its eyes to the sky. Yet here we are, a species capable of wondering, of asking questions, of imagining distant stars and hidden companions. The universe created complexity, and in time it created minds capable of contemplating that complexity. That may be the most beautiful connection of all. So as you allow yourself to drift deeper into rest, carry with you this quiet perspective. We are small within the cosmos, yes, but we are also participants in its story. Every breath you take, every dream that forms tonight, happens within the same universe that shapes the paths of galaxies and stars. You are part of that same cosmic rhythm. Now let the thoughts slow. Let the mind become still. The mysteries of the universe will remain where they are, waiting patiently among the stars. For now, simply rest. And if you enjoy exploring the quiet side of science like this, you're always welcome to return and continue the journey with us here at Cosmos for Rest, where the universe unfolds slowly, gently, and one peaceful story at a time. Sleep well.